our next task is the same counter but using interrupt signal. So the title is design a counter using interrupt operation in Arduino. So this is basically the code, and the circuit is almost similar to our task 1, that's why I didn't show it here. So I will demonstrate it. First let me open the code. So I will open our task 2 interrupt, this one. I may close this one, now this one. So you may know that interrupt is some sort of signal, and there are different types of interrupt, for example software interrupt or hardware interrupt. As the name suggests, interrupts, that means it will interrupt some existing works. Let's say you are operating a motor using your Arduino, but there are a high priority signal to turn off the motor, let's say for an emergency. So to simulate this or to perform this high priority task, you need to use that interrupt. That means whenever that interrupt will be issued, then obviously all other tasks will be closed. That we call interrupt. In Arduino Uno, button 2 and button 3, pin number 2 and pin number 3 are actually interrupt pin. So using pin 2 or 3 you can simulate or you can perform the interrupt operation. That's why we have used pin number 2 here. So define button 2, we are using pin number 2 as our interrupt operation. Then this portion is similar, so we will be start our count. Then this serial begin is also similar to our previous program, but this line is new. So we are performing some interrupt operation, and to perform some interrupt we need to mention it in void setup, and the code is attach interrupt. So by using this function attach interrupt, you are generally attaching interrupt to a pin. That means you are saying that I am using this pin as interrupt signal, so whenever I will give some signals, some predefined signals, you will give me priority, that sort of things. So attach interrupt, the arguments and the arguments and parameters are, first parameters is digital pin to interrupt. That means you need to define which pin you are using. So I am using this pin number 2, that is the button. So digital pin to interrupt is another function which generally tells you which digital pin you are using as the interrupt pin. That's why digital pin to interrupt, then button, first argument. Next argument we call it interrupt function or interrupt routine. So whenever this interrupt occurs, we want to perform some another task, obviously. So we need to define that task using another function. So this is the function name, counter function, FCN. So I define this function as here void count function. So whenever that interrupt signal is provided, it will perform this function where I return that count equal to count plus 1. So it will increase the count value and it will print that count value to serial monitor. So whenever I will give the interrupt signal, it will increase the count and show it in the serial monitor or virtual monitor in our case. And the third, this is the mode. So any signal has 3 or more types of values. So if I show you, let's say here, so the digital signal looks like this. So 0, then 1, then 0, then 1, this like. So this is the 0 level, I can say low level, and this is the 1, that is high level. So sense, there are different modes. One is sense. So sense means either 0 to 1 or 1 to 0. This is called sense. So if I write here sense, then whenever our at pin 2, whenever we will sense either 1 to 0 or 0 to 1, interrupt will work. And another mode is the rising mode or falling mode. So rising means from 0 to 1. So if I write there rising, that means whenever the signal goes from 0 to 1, interrupt will occur. and another is falling, that means 1 to 0. So whenever the signal goes from on to 0, interrupt will work. So these are most common modes I just demonstrated. So this is the main function or main line in this interrupt code. And in the void loop, you generally know that whatever we write in the void loop, this will be operated, right? So in this void loop, we are just showing a great delay. For example, here a massive delay we are simulating. So if there aren't any interrupt function, so obviously the program will stuck here. There is a big delay, so program will stuck here, nothing will work. But we are simulating some interrupt, so in general program should stuck here, but using that interrupt signal we will make program work out of its stacking. So we will count the counter, but this count is not written in void loop, if you notice. So we are not performing this count in void loop. So in general this counting shouldn't work, but we will be working this by using interrupt signal. So that's all. Now if I click on this verify, and in the schematic I need to send something as well. So I need to connect this to pin number 2 since I am using the interrupt operation. So first of all I need to select this wire to delete this, and then I need to connect to it pin number 2. So now the circuit configuration is done, and now I need to include the hex file location because we are performing another use case now. Now this is task to interrupt, so obviously the hex file location or name changes. Now it is task to interrupt, so that's why I need to select it again, Control C, then here double click, and then here Control A. I just selected all to replace it, then Control V. Now okay. So I just uploaded the program here. All I need to click on this run this simulation. So now run this simulation. Simulation is in progress. So okay, one more thing, I may, now it is open. So let's start from beginning. So if I run this simulation now, obviously the push button is turned off. So basically the Arduino is now stuck in this delay because there is a massive delay. You can increase the delay as well, that will be no problem. So now it is in the delay, but if I click on here, that means I just change value 2 times, because first of all it was 0, I changed it 1, and then I release it. That's why it again changed to 1 from 0 again. That's why it counted 1 and 2. I am showing you again. I am just pressed it, so just pressed on time, that's why it has counted to 3 on increased, and if I release it will count again. So now 3 to 4. So I just say clicked, so it count 5, and then release count 6, because it is sensitive to the change in value. So I am just changing. If I make it like this, so it just counted 1. Now although it is taking one logical 1 value, it is pin number 2, but it will not increase its count variable. Why? Because in the program, if you notice here, here we just written whenever we got the interrupt signal, that is whenever we got any change either from 1 to 0 or from 0 to 1, we will be increasing this count variable. But in case of our first program, this was different. Here whenever the button state 1, that's why in our first task, when we pressed this button and take as it is pressed, then the increase, the count increase was continuous, because we written here button, if button state equal to 1, count will be count plus 1, and it will be continuous since it is in void loop. But in case of our interrupt task, it will depend on this interrupt mode, and we return it to change. That's why whenever some change occurs, it is increasing. Now the procedure in Arduino Uno, interrupt pins I already mentioned, and the fourth point, observe the effect by changing the attach interrupt mode to rising and falling. So I am changing to rising now, and I will show you what are the effects. So rising, so if I write it rising and then verify, let's go to our Proteus. So stop the simulation, and now it is released. So I think the program has been done compiling. So yes, so it is done compiling. Now if I click on this run the simulation, so initially obviously nothing happens, no change occurs. So whenever some rising value occurs, so what do you mean by rising? From 0 to 1. So if I click here, so now it moved from 0 to 1, right? So 1 came here, but if I release now, no count will occur. Why? Because if I release, then it just occurs on to 0, and we are performing just the rising operation. That's why if we just click here, on increased, now it will be 3, and if I make it pressed, so now only 4 times we got, and if I release it, no sense, because when I released it was from 0 to 1, sorry, it was from on to 0, but we are performing our interrupt in a rising mode. So in your homework you will sense it as falling as well, and you will observe that whenever the push button goes from on to 0, then it will change its count value to 1, and you should discuss it in the report. So task 2 is completed. Thank you.